QSO Today, Episode 513, Lee Barrett K7NM. This episode of QSO Today is listener-sponsored. Only you can keep the QSO Today podcast coming to you every weekend since 2014. Please become a listener sponsor monthly or annually by clicking on the sponsor banner on the show notes page or at the top of the QSOtoday.com webpage. My management system automatically posts payments made to QSO Today podcast on every week's show notes page, as well as a running total of payments made since the podcast began over 10 years ago. I want to thank the listener sponsors who make regular payments to the QSO Today podcast. They are listed on the show notes page. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio? Do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. Before we start, I wanted to update you on the best way to listen to the QSO Today podcast, or any podcast for that matter. QSO Today, along with over 4.2 million other podcasts, both active and inactive, is registered on podcastindex.org, an open-source blockchain network that updates Podcast 2.0 players in real time. This index is spread around the ability of any podcaster to publish regardless of the mood, political ideology, or subject, etc. It is one of the few free speech mechanisms left in these days that cannot be closed, edited, or blocked. I bring this to your attention to let you know that there are links on the QSO Today website to Podcasting 2.0 players that work extremely well to guarantee that you always get your podcasts on any subject all of the time. Please support the creators of these apps by using their players and donating to them the value that these players bring to you. I still listen to about 20 podcasts per week while walking, driving, and cleaning the house. They keep me entertained, updated, and informed. Lee Barrett K7NM has had a wonderful career in broadcast radio, military projects, command and control, spacecraft, and medical device development. His early initiation into amateur radio set in motion all that came later in both his professional and amateur radio life. From early in his ham radio career, Lee published papers on vertical antenna beam tilt for repeater networks, as well as his most recent C-match method for phasing HF vertical antennas. Lee was a presenter at the QSO Today Virtual Ham Expo and speaks to radio clubs all over the United States and at the Dayton Hamvention. K7NM is my QSO Today. K7NM, this is Eric, 4Z1UG. Are you there, Lee?
Yeah, I am, Eric. Nice to see you today.
It's nice to see you, Lee. It's a beautiful day probably in both places here in the middle of the summer, right?
Yeah, it's pretty hot here. It's been over 100 degrees the last couple of weeks, Fahrenheit.
It makes you appreciate air conditioning.
Yes, it does. Fortunately, we have central air conditioning, so it's not so bad.
We don't. We have these split systems all over the house. That's kind of the way we do it here. Lee, let's start at the beginning of your ham radio story. When and how did it start for you?
Well, we were down in a sabbatical leave from my father. He was a math professor at the School of Mines and Technology in Rapid City, South Dakota. And he had done some work for the Navy at China Lake at the Naval Weapons Center in California. So we were down there for a year and a half sabbatical, and I was 12 years old. I was in a Boy Scout troop, and I went to the Scoutmaster, and I said, I want to get a merit badge that nobody else gets. And he said, great, get radio. And I said, I don't know anything about radio. And he says, why do you get merit badges? And I said, good point. So I got the book, and my mother went to the local radio and TV repair shop, which back in those days were prevalent everywhere. And they ordered all the parts for a receiver that you had to build, which was built out of a 3A4 tube. And it ran with a 1.5 volt dry cell on the filaments, and it had a 45 volt battery for the plate. And I was terrified of that 45 volt battery. I knew if I got across that, I was going to be killed. So I was very careful not to do anything in the circuit with that thing hooked up. So I started working on this receiver, and I couldn't get it to work. It absolutely would not work. And all of my Elmers or merit badge counselors could not help me get it to work. We moved back to South Dakota after a year and still couldn't get it to work. And I spent almost every night trying to work on that thing and get it to do something. So I took a piece of plywood and drew the circuit on it and laid all the wires out and all the components on it, like the schematic, and hooked it all up, and it still didn't work. So one night I was sitting there with the headphones on, and I forgot to disconnect the 45 volt battery. And I touched one of the solder joints, and a wire popped loose, and the receiver came alive. And I could hear shortwave if I loosely coupled the antenna, and I could hear local AM broadcast if I tightly coupled the antenna. So that was the first success after 2 years, and I got my radio merit badge. But in the process, my grandfather came to visit in South Dakota. He knew I was interested in radio, and he saw an ad in the paper for a novice class at the local fire department. And so I went to the novice class, and I managed to pass my novice class license, and got the call WN0LXM, and we were off to the races. So that's how I began ham radio. I was 13 years old at the time.
And what year was that?
1965.
And so then what was the novice rig?
Well, I didn't have any money, and my parents weren't terribly supportive of this newfound distraction that I had. So what I had to do is go down to the local TV and radio repair shops and get their permission to go through the junk in their garbage. And I'd pull out old TV hulks and old radio hulks and bring them home and cut all the capacitors and resistors out of them. This is all tube type equipment, and drill out the tube sockets. And so anyway, long story short, I built a transmitter out of two 6L6s, and one for the oscillator and one for the final. So it was about 30 watts output, maybe, if you were lucky and it was a good day. And the receiver was a Star Roamer. My folks gave me that for Christmas, which was a night kit that I had to assemble. And that was my first station. And I think I made one contact across the city once with that. So it wasn't terribly efficient, and I knew absolutely nothing about antennas at that point in time. And so that was the first rig. The second rig was I bought a couple of old Arc 5s from my scout advisor right before we ended up moving to New York. And we moved to New York in the middle of 1960, would have been 4, to Potsdam, where my dad became head of the math department at Clarkson College. And the good news is he had a fellow working for him in the math department who was K3VXV, who today is K3VX. And he became my Elmer. So he kind of put his arm around me and taught me about antennas, and we built a couple of trap dipoles together, and he put one up and I put one up. We lived pretty close to each other in a couple of faculty fourplexes. Anyway, I owe my ham radio career to Larry. Larry Comden is his name. He lives in Pittsburgh now, in the Pittsburgh area.
It seems to me that your novice experience, at least until you met Larry, was kind of a frustrating operation in terms of getting on the air.
Yeah.
Were you just kind of in love with the handling of the components and doing the building any way that you knew that at some point you'd have more success?
Well, yeah, I mean, the ARC-5s, I had to be crystal controlled. And so I built the circuit that was in the handbook, the ARRL handbook, and it didn't work. And so I had to come up with my own circuit and got that to go. And of course, it needed all these high voltages. And so I ended up building a power supply with a bunch of OD3s in it for voltage regulators. And finally got on the air with the ARC-5 on 80 meters and 40 meters. I had one of each. And it was frustrating. You got that right. Again, I had no real support from my family, but it kept me off the streets, so I was happy with it. I had a lot of Elmers along the way that helped me out. One paraplegic fellow in New York who would have me come over to his house and run his NCX3 and actually make a few contacts once in a while. Frankie Knight was his name, and I don't remember his call anymore. That was over 50 years ago, but it was build stuff and try to make it work, and that's the way it went.
We're on video right now, and you have your back to your ham shack full of amazing gear, and you have a long history in electronics. So I'm assuming that your interest in amateur radio went beyond your high school years. What happened after that? What choices did you make?
Well, I think there's one key thing that happened before my high school years that I need to mention, and that is that we were living in Potsdam, New York, which was 132 miles from Manhattan, which was the nearest FCC examining port. And in order to take the conditional class license, you had to live at least 135 miles. So I'm 3 miles short to get my conditional class, and my novice was running out. It was a 1-year non-renewable license. And here I am, 14 years old. So I wrote to the FCC and I said, look, I'm 14, I'm 3 miles short. Can I take the conditional? Can you give me a waiver? And they wrote back and said no. And as a miracle, it turned out that my father had to go give a paper in New York City in April, which was when my license expired. And we were down there near Connecticut over Easter. Larry, K3VX, was in Connecticut visiting his in-laws, and he went out of his way to drive down and pick me up at the hotel in Manhattan and take me down to the Federal Building to take my general class license while my family went out to see the Statue of Liberty. And so I took the general class in Manhattan and passed it, and I became WB2 UKO. And it turned out that Larry took me to Radio Row right afterwards in New York to see the place, which was just amazing. You can't even describe it. It's just block after block after block of radio and electronic shops. And that all went away 6 months later when they built the trade centers. And so I got to see it before it was taken out, and it was pretty famous for a number of years. So if Larry hadn't have done that, I would not have gotten my general class license. And so that was a major milestone that had to happen, or I probably would have gone the way of the earth as far as ham radio went. So after that, I got pretty active. I ended up getting a DX60 for Christmas, and I bought a Hallicrafters receiver at a ham fest, and that became my station. And then we moved to Montana. I was WA7HDD there. My dad built a ham shack out behind our house and put some masts up to hold the antenna. And the real reason for doing that was because my bedroom was next to his study and he didn't want the noise. So he put me 50 feet behind the house where I couldn't bother him. And it was really a blessing because I spent a lot of time out there, not only on the air, but building circuits and learning about the different aspects of electronics. I built my own first linear amplifier when I was 16 out of a couple 4-400s. And that was an experience, learning about high voltage and RF shielding and all kinds of stuff like that. it's a wonder I didn't have a lot of accidents being that young and playing around with that stuff. I actually built another amplifier with some 450 TLs, which were neutralized, and I had a bumblebee fly through the window one summer night through the neutralizing capacitor, and it not only blew the bumblebee to pieces, but it blew all the fuses out of the power supply too. I had a 10-year-old kid in there watching my ham radio activities that night. He got covered with fuse parts and was terrified. But he went on and got a master's degree in electrical engineering and became a microwave engineer. So I guess it didn't hurt too much.
You must have impressed him. Did you have fellow friends, kids your age, when you were back in Montana and operating in your ham shack? Was there a ham radio community for you?
Yeah, actually, there was a local club that was very active, and they were very welcoming to me. But the other part that was really kind of cool was that there were two other kids that were my age that were both hams, Doug Ballard, WA7DCF, and Matt Montaigne, WA7GHW. And the three of us ended up getting hired by W7LR for the summer, our sophomore year, to work at the Electronics Research Lab at Montana State University. And we got to do all the grunt work. We got to pack a prefabricated building up the side of a slope of a ski hill and assemble it on top of the mountain and then put a weather station inside of it. That took us all summer. But we became fast friends, and Doug went on to get a master's degree in EE, and he actually invented the hard disk at Hewlett-Packard and got the patent on that. And then he came down here to Utah and started a company called iOmega, which built the zip drives. And he did very well. But he passed away at the age of 55 with kidney cancer. And Matt is still doing well. He went into the camping and horseback experience for kids from the east down at the Tetons in Wyoming, and had a dude ranch, and he sold that off and did very well. He still lives in Jackson Hole and has a home in Maui as well. So the three of us have been long time friends as far as ham radio is concerned. So, yep, had both. But one of the key points for me was at the electronics lab, there was a fellow named Ken Marcotte, and he was a ham too, and I forget his call. But Ken came to me one day, and he was kind of a scouter guy. And he said, why don't you see if you can keep up with me on licenses? And he says, I have my extra class ham license, so why don't you see if you can get that? So I did. And then he got his first class radio telephone license, commercial license, and I got that. And then he went and got a second class radio telegraph license, which is a toughie. And I got that. So by the time I was 18, I had all of those licenses, and I've held them since.
I understand that the second-class radio telegraph license was actually quite difficult to get.
Yeah, you had to send and receive 16 words a minute and 5-letter code groups, including punctuation. And then after you passed that, then you had to send and receive 20 words a minute in plain language. During that, you had to send it 20 words a minute with a straight key, and that is not easy. And then the third class written test is pretty simple. It's all about radiograms and radiogram types of formats and such. But the second class telegraph exam was one of the toughest ones I ever took, because it's all about maintenance of Edison batteries on board ship and different things that had to do with shipboard activities. But also, I had 10 questions at the end where you literally had to draw schematic diagrams of things that they told you to draw schematic diagrams of. And so it took about 6 weeks for that thing to be graded, and I passed it. So I still have my radio telegraph license. The only way you get first-class radio telephone is to go to sea or to work at a Loran station for a period of time. You have to have experience to get the first. My wife took a dim view of me doing that, so I didn't ever get anything but second class.
All of this paper that you collected, did any of these licenses help you later on? Did they give you entree into college and your college studies? How did your life proceed after that?
Well, I always knew I wanted to go into electrical engineering, and I had been working at the research lab for a couple of summers before I ever got to college. And so I knew people, I knew the professors, I had worked around them. And so I was kind of a piece of the furniture by the time I got to the college. The licenses, interestingly enough, were recommended by one of the technicians at the research lab. He told me, if you got your first-class radio telephone license, you could be a broadcast engineer or you could be a two-way radio technician, and that would be a great fallback position to have if you were out of work. That made sense to me, and so, yeah, I carried those. And once I got out of graduate school, I was enamored with broadcast, and I really wanted to own a broadcast station. And I didn't have a chance to do that because I didn't have any money. So I did the next best thing. There was a small market radio station on the northern border of Montana, in Havre, Montana, KOJM AM and KPQX FM. They were having problems. They'd had some fines from the FCC, and I found out about the job and went up and interviewed, and they hired me on the spot. And yeah, I had my first-class radio telephone with radar endorsement on it, and so that allowed me to be the chief engineer there. And they needed to have a first phone because they had two directional patterns, day and night, and you had to have a first phone engineer available in order to be a chief engineer at a directional station. You had to have a first phone. So, yeah, that got me my first job.
And now this mid-show break. The QSO Today project that now includes 500 episodes of the QSO Today podcast, the curation of hundreds of hours of QSO Today Virtual Ham Expo presentations for public consumption, is now supported completely by you, the listeners. I am using a business model called Value for Value, a concept developed by Adam Curry, K5ACC, where you contribute to QSO Today exactly what you think its value is to you. Value for Value. This mid-show break and the promotion of the Ham Radio Workbench podcast later in the show are the only commercials that interrupt the program. QSO Today has no commercial sponsors to influence the content, direction, and editorial content of the QSO Today project, which exists solely for the promotion of the amateur radio hobby. Those of you that have listened to over 500 podcast episodes know that I'm not only infatuated by the amateur radio hobby, but by the people who perpetuate it as well. The hours that I dedicate to QSO Today is a half-time job. Your support at any level pays for all of the technology that I use to create, produce, host, and deliver the QSO Today podcast and the project to the ham radio community. And while it is a labor of love, it costs money. I know from statistics and surveys that only 6% of you actually contribute to QSO Today in some form. Please make a generous donation using the slider to set the amount of your donation. Make that donation monthly to ensure that QSO Today is here for the next 500 episodes. As a value-for-value donation, it should be in the amount that you value each episode of QSO Today, or your access to our amazing catalog of ham radio educational videos found on YouTube, Vimeo, and using our own player, link in the show notes page. Become a listener sponsor monthly or annually. Use my Amazon link in the right column of the QSO Today website before shopping on Amazon. Promote QSO Today your friends and family by forwarding our email and social media posts. Subscribe to our mailing lists. Subscribe to the YouTube channel. Tell your friends. All of these actions are value for value. Keep the QSO Today project alive by taking action now. we return to our QSO today. I see from your bio that you worked for the U.S. Air Force in guidance and communication systems. How did you find yourself in the United States Air Force?
Well, I never was in the Air Force. I was a Vietnam-era kid, let's put it that way. And I had a very low draft number. It was 55, and they were taking everything from 172 below that. And most of my friends all went. I've got one friend that served 3 tours in Vietnam as a Marine and then became a highway patrolman. And so I figured I hadn't really done my bit for God and country. And so after I got out of broadcast, I figured I'd go to work for the Air Force for a couple of years if they would take me as a civil service engineer. So I put my application in and I got an interview from them, and lo and behold, they hired me. So I'd planned to be there for a couple of years. And by the end of 2 years, I was head of operational engineering for the Utah Test and Training Range. And so I figured, well, if I can excel that far in 2 years, then maybe I'll stick around. Well, in year 3, they had a highly classified project come in. And by that time, I had ticked off most of the engineers in the squadron. So they didn't clear me for the project. And they worked on it for 6 months trying to get telemetry data from the Dugway Proving Grounds area back into Hill Air Force Base, which is about 150 miles on microwave. And they couldn't do it. And I came in one day after I got back from management training, and the range control officer and I were friends, and he couldn't talk to me about the project, so he'd ask me 20 questions all the time to try and get information. And I was having one of those sessions when the commander walked in. And the commander said, "You two sit down and don't go anywhere." So we did. And he said some things to Jim, and then he turned to me and said, "What do you think?" And I said, "About what?" And he said, "Why we can't get telemetry data out of this missile." And I said, "I have no idea what you're talking about, sir. I'm not cleared." And he screwed himself into the ceiling and turned to Jimmy and said, "Why isn't he cleared?" And he said, "Well, he's not on the list, sir." And the commander said, "He's on the list now. Tell him what you know." And so he started explaining to me their issues, and it was just a simple solution to Carson's rule. So I got the data rate and the deviation of the transmitter and the bandwidth of the microwave, and told him, "Well, sir, your problem is you're trying to put 5 pounds of sand in a 1 pound bag, and it's not going to fit." And he said, "Just like that?" And I said, "Yes, sir, just like that." He said, "Well, how come those other idiots can't figure that out?" And I said, "I'm sorry, sir, I can't speak for idiots." And so he said, "Well, can we fix it?" And I said, "Not without a couple $1 million and a couple of years to install a new microwave." So he said, "Well, what are we going to do?" He said, "We're going to, I'm getting calls from the Pentagon. I'm getting calls from Wright-Patterson every day, and they want to know when we're going to fly this thing. It's been 6 months." And I said, "Well, sir, since this is a black world project, you're not going to watch this on television, are you?" And he said, "No." I said, "Well, then why don't we pull the cameras off of the video microwave and put the data down the wideband microwave?" And he said, "Well, can we do that?" And I said, "Well, give me a couple hours and I'll tell you." So long story short, it took those guys 6 months to try and get the telemetry data in, and the commander gave me 4 days, and we flew the missile and had beautiful telemetry data. And out of that, the head of the Utah Test Range, who was a retired lieutenant colonel fighter pilot, got fired. And computer sciences, who had the contract there, came to me in the back room and said, "Do you want his job?" And I said, "Well, put your money where your mouth is." So they doubled my government salary, and I went to work as the head of the test range. And that was at the ripe old age of 33. And I ended up with 85 people at 5 locations reporting to me. And I ended up staying there another 7 years. And so that's kind of how it all came about.
Well, I see that you made a transition then from communications and guidance to medical technology. Was there some relationship in terms of what you'd been working on at one side that could transfer over to the other, or were you just looking for something new?
Well, my focus with the Air Force initially was in radar. And when I walked in the door from broadcast, I had no idea of what went into tracking and metric radar. So I spent a lot of time reading Skolnick's books and going up to a training class in Florida and then getting out in the middle of those radars and learned everything I could about them. And there's lots of stories I could tell you about that, but we don't have time for that today. And so there were things about the radar systems that I had learned, like how a frequency shift reflector works and some other things that are used in the calibration of radars. And so when I got the call from my former radar engineer from Utah, I was down at Nellis Air Force Base at that point in time. I'd moved from Hill in Utah down to Nellis in Las Vegas, Nevada. Where down there, the mission was different. There we were training air crews to survive combat. I was working for Lockheed at the time, and my old radar engineer called me from Utah and said, I just started working for a startup medical company here in Utah, not at the Air Force anymore, and we need somebody to design the next generation blood monitor for dialysis. And it's supposed to be optically based using LED light. And he said, do you want to take that on as a side project? And I said, well, sure, why not? So I picked a good hardware guy and a good software guy from companies I'd worked with in Las Vegas. And we formed a little group around my kitchen table. And over the next 7 months, we designed this dialysis monitor. And there are two different methods of radar that were used in that monitor. One of them got us completely away from being sensitive to ambient light. So the detector system doesn't see ambient light at all. And the second part of it was a signal processing method, which allowed us to increase the signal to noise by a factor of 100. And so this device ended up being released in 1997. We just put it to sleep in 2021, I think. So it had a long history of being very, very useful and successful. There's about 800,000 treatments a month being given today with that technology. We've done 4 more generations of that same device, but made it smaller and made a USB peripheral out of it, actually. And so that radar background certainly helped with the medical transition. I mean, when I came up here and met with the doctors and the engineers at the medical company, I couldn't even spell hematocrit. I didn't know what that was. So it was a grassroots, get in the middle of it and figure it out. So did have some experience with processing signals out of a lot of noise, which is what you do with the radar systems.
Do you think that your approach to problem solving, both at the Air Force and in the medical equipment business, do you think that approach is kind of based in your amateur radio career? Are there things that amateur radio operators learn that perhaps people without that background don't learn, and so therefore they're not open to seeing the possibilities?
Yeah, I got to tell you, I had a Cinderella career. I got to work in lots of things, and amateur radio gave me the background to understand what I was looking at. I mean, everything from tracking systems at Cape Canaveral down to old tracking systems that were put in by the Germans at White Sands, down to telemetry systems at Vandenberg. All of them have a basis in radio and basic radio electronics. And the cool part about it is because of ham radio, I was down into the deep and basic bowels of the circuits because of how much building I did and how much self-teaching I did when I was young. When I got older and I went through the standard electrical engineering curriculums at the university, the kids that went out of the school there didn't have the benefit of having the hands-on level of technician capability that I had. And so I could tie the principles of electrical engineering to the actual circuitries that I was looking at and working with. And it all came back to the origins of being a ham. I was inactive as a ham for about 25 years because I'll be honest about it. When you're working in microwave and radar and telemetry and all of that stuff all day long, to come home and ham is too much different or fun. But I did get enamored with phased arrays when I was in graduate school, and so I did do a little bit of work with that while I was some semi QRT.
I want to talk about that because I actually found an article that you wrote in May 1983 for Ham Radio Magazine, where you were talking about repeater antenna beam tilting. And my awareness of that was growing up in Southern California, we had these enormous mountains over the LA basin where if your repeater was on Santiago Peak, 5,600 feet above the average terrain, then you actually had to know something about beam tilting just to be able to have coverage at the bottom of the mountain, which is where you were. So I saw this article, and a link to it is in the show notes, but it seems to me that you actually had some actual requirements where you actually had to put into action the things that you were learning about phasing and stuff in order to solve some repeater problems. Could you talk about that?
Yeah, of course. This goes back to the broadcast experience because KPQX-FM was sitting on top of an 8,000-foot peak above the city that was at 2,000 feet. And the broadcast antenna that was up there was a 12-bay antenna up the side of a 150-foot tower. The bays were phased with a negative 3-degree beam tilt. Because the problem is that when you get up that high and you squirt out your signal horizontally, the earth falls away from your signal faster than your signal gets down to the earth. And so you have to tilt the beam in order for signal to get down to the ground. Otherwise, all you're doing is you're just heating up the ether with your power. So it seemed to stand to reason that the mountaintop repeaters with their big 23-foot collinears that are squirting all their signal out horizontally really aren't doing a whole lot of effective coverage of their area. So the idea is to take a Cushcraft 4-pole antenna, which they don't make anymore, I don't think. And it basically had 4 phased dipoles down about a 26-foot pole that were spaced a wavelength apart. And they were fed with 72-ohm coax to a T-connector, which if you do the math and the Smith chart stuff, you find out that if you take 2 50-ohm loads and put them a quarter wave apart on a 72-ohm coax, and then put a T-connector in the middle, converts it from 50 ohms to 100 ohms, and then the 200 ohms are in parallel, so you're back to 50 ohms again. And so it's a power divider, and it works really well that way. And so what I did is on the ends of those power dividers, I calculated what a 50-ohm delay line would have to be for each antenna to give a 3-degree phase shift downward. So I put 2 4-poles up at our FM site, one of them about 20 feet from the other one. So they were pretty close together. And one was phased and the other one wasn't. And then I ran some tests on mobile stations that were heading south of us in Montana down into the Missouri breaks, where you drop down very quickly, probably 300 or 400 feet, then cross the Missouri River and then come up the other side about 300 or 400 feet. The stations that had no phase shift on them would just drop out. They'd go down into that area and the 2 meter signal would just completely disappear. But with the beam tilt, you would get some soft hissing on the station, and that's about as bad as it got. And then it would come back up the other side, and you never did lose total communications with that mobile station with that antenna. So that was kind of the beginning of the idea of beam tilting the antenna for mobile stations and getting things down to the ground from a high repeater point.
That's what we learned as well. Phelps Dodge 10 dB stick is an amazing thing on the ground, but on a 5,600-foot antenna, you had an amazing signal in Santa Barbara.
Yeah.
But that was 150 miles away, so that was a very interesting lesson in those days to learn. You gave a presentation at the QSO Today Academy. I'll put the link to that video up, where you become very interested in phasing vertical antennas in order to create directional arrays with vertical antennas. The name of your presentation was C-Match Method of Phasing Vertical Antennas. I think you even have a book out you can purchase through DX Engineering. Could you talk about C-matching vertical antennas and what you've learned from that?
Yeah, in graduate school, I had to take an antenna course, and I had to do something special for it to get graduate credit. So we had a AM station there in Bozeman called KBOZ. They had a 5-tower array in a line, and so I built a little field strength meter out of a transistor radio, and I went out day and night and measured their pattern. And I was sitting one night less than a mile from the center tower, and they were running 5,000 watts, and I could not hear them. The null was so deep in their pattern that they were just gone a mile away with 5 kW, and that really impressed the heck out of me. So I ended up in broadcast, as I mentioned before, and I had 2 antennas there that were 368 feet tall and 408 feet apart. And I had to take care of that phased array. And I had similar experiences with that. I was in Great Falls, Montana one night, and I had them go to day pattern, and we were as loud in Great Falls as the local stations. And then they hit the night pattern, and we totally disappeared. Could not hear us at all. And that was really interesting to me. So I thought maybe I could do something with that with ham radio and put a 20-meter array together that would be similarly performing. The trouble with the broadcast side of things is that everything's done with coils, and power dividers are all coils, and everything in it's full of coils. And whenever you're running power into coils, you're losing power because of the resistance of the coil. And so I took a look at a different approach where I didn't want any coils in my system. And so instead of trying to take the coils and make your antennas taller, instead I make the antennas too tall and make them shorter with capacitors, because you don't lose anything in capacitors. And so then it came down to how do you do a power divider and how do you put the phase shift in and all of that. And it turns out that using a combination of transmission line theory, antenna theory, and linear circuit theory, you can model the phased array and do everything with 72 ohm and 50 ohm coaxes and a couple of capacitors at the base of each of the antennas.
So what happened after that with this approach to phasing 2 antennas?
I worked on this for 25 years. I read in the handbook where there was kind of a statement in the antenna handbook in the phased array section that said, if anybody can figure out how to do a broadband power divider, then we'd sure like to hear about it, kind of thing. And so the gauntlet hit the ground, and so I went to work. And I found out that I could use quarter wavelength sections of coax and used them as a power divider. And that worked out really well. And then I had to match the impedance of the antennas. And so I made the measurement of the base of the antennas, and you can go through and calculate what the mutual coupling is, because the closer you put antennas together, the more mutual coupling. And so you have to take that into account. And that, by the way, is why guys take two 2-meter antennas or something, and they tune them to resonance, and then they stick them close together, and all of a sudden they got a bad SWR and the antenna doesn't work very well. And that's because if you don't take into account the mutual coupling, then the pattern doesn't form. And you also have to have equal power division between the antennas, or the null doesn't form. And so anyway, so I put this array in. I kind of got the brain fart at Dayton at the hotel one night when it all came together. So I came home and put my 20-meter array together. And I already had the verticals put into the backyard. I put in the radials before we put the grass down. And I put my two 20-meter verticals up, and I built the feed system. And it took me about 40 minutes to tune it up, and I ran that thing for 3 years. Rain, sleet, snow, didn't matter. And the SWR was flatter than a pancake across the entire band. And the pattern holds together across the entire band, whereas the other systems that you see, the pattern will only hold together over maybe 10 kilohertz. And so that's another big benefit of the C-Match. And so it worked really well, and then the 20-meter band kind of went dead. So I decided, this is on the back end of the sunspot cycle last time. And so I decided, okay, I'm gonna defy gravity here, and I'm gonna try something new. So I ordered a couple of 40-foot verticals. By the way, I make the 40-foot or the verticals out of 3-inch diameter aluminum irrigation pipe, which are used out in Idaho and other places. And they delivered those, and I put them up, and they're only 18 feet apart, 17 feet actually. So they're an eighth of a wave apart, two 40-meter verticals. And I was able to get that tuned up in about 20 to 30 minutes. And I got on 40 meters CW with my 100-watt rig and tuned in on 7X4AN in Algeria, calling CQ, and a big pile up on top of him at about 6 o'clock at night. And I called him and got him on the first call with 100 watts. And I said, I think it works. And so over time, I did a lot of receiving, and I had a gap challenger out in the backyard I used for an omnidirectional reference antenna. I did this A-B type stuff between the phased array and the challenger, and I found that the nulls in my 20-meter pattern were about 42 dB deep, and the nulls on my 40-meter array was about 38 dB deep. So the patterns formed and the nulls formed, and it worked really well. And it's pretty easy to build and pretty easy to tune up. And you just need a VNA or an RX bridge and a couple of El Cheapo SWR bridges from the CB realm that you can get at any truck stop, and you're off to the races. So.
And now this mid-show break. Every 2 weeks, I listen to the Ham Radio Workbench podcast with George, KJ6VU, Vince, VE6LK, Mark, N6MTS, Thomas, K4SWL, Michael, VA3MW, and Rod, VA3ON, and their guest on often topical and important projects in amateur radio. This discussion amongst the regulars and their guests remind me of the conversations that I used to listen to on 146.94 and 146.46 megahertz in Orange County, California, while working on my own workbench almost 50 years ago. It is amazing how much practical ham radio knowledge that we can absorb by listening to the Workbench podcast that starts to make sense when we start our own deep dive into our own projects. So join me by listening to the Ham Radio Workbench podcast now, and as George and crew push beyond 200 episodes. You can get to the Ham Radio Workbench podcast by clicking on the banner in this week's show notes page. And now, back to our QSO. With 2 elements, that means that you can switch that array in 2 directions, front to back, back to front, or do you actually have control with just 2 elements to be able to change other directions?
That's the beauty of this C-match system, is that the direction that you put your nulls in, which is really what phased arrays are all about. People think that you build them to put a lobe somewhere, and that's not the case. It's all about nulls, and that's why they use it in broadcast to protect other stations. So you can steer your nulls, which will also affect where your lobes will form, because the power from the null has to go someplace. And you can actually steer the direction, but you have to do it with the placement of the antennas, the spacing of the antennas, and the actual phasing between the antennas. So I can get a particular pattern to the east, but I have to put in a different C-match to do it west, because the mutual coupling switches. And so the base impedances change because of the phase difference going the other direction. So you have to put in a second C-match for the other direction that you're going to switch it to. And that's not difficult. You can do it with some relays. And I talk about it in the book. It covers that.
So to tempt people to buy the book, are you remotely controlling, say, the capacitors with servos or something like that in order to tune them remotely in the field?
You could do that if somebody's brilliant with stepper motor control and software prowess, which I don't have. You could actually do that. You could switch in a different phasing section and then have the microcontroller look at the SWR and the power division between the antennas and optimize the capacitors to tune it. I have not gone that far. I'm more of a manual guy. I have to go out there and stick my bridges in there and tweak the capacitors by hand. It's not too bad. You can just go back and forth between the 2 antennas until you have equal power and the best SWR you can get. You're not going to get 1-to-1, but you're going to get something that's tolerable down around 1.5 to 1 or something. But the big thing is that the forward power has to be equal, because if you don't have that, then the nulls don't form.
So I have a backyard that's about 35 feet wide. Is that too small for a 2-element phased array?
Depends on what band.
20 meters. It's a wavelength between verticals?
No, mine's a quarter. And you can do it less. Like I was saying, I put 2 40-meter verticals an eighth of a wave apart and still had it work pretty darn well. But you do need a good ground radial system. And I have 45 20-meter radials under each vertical, and they work really well on 40. And the reason for that is because I put a perimeter wire all the way around the outside of the radials. And so that made a big, huge capacitor plate out of the radials. So it couples to the ground better than putting out individual radials. And not only that, it's better for lightning, because if you have a lightning strike half a mile away, there's going to be a voltage gradient that comes off of that, and it's going to travel through your ground system. And you want your ground system to be equal potential. You don't want any gradients across your radials, because that's what's going to cause damage. So when you loop them together like that, then it takes voltage gradients and converts them to circulating currents. And that makes the whole ground system at equal potential.
And because you're able to control the direction of the nulls, then your antenna could be nulled away from, say, electronic noise coming from the house.
Yeah.
One of the biggest problems that people have with vertical antennas in their backyard in a city lot, for example, is just electronic noise that is pervasive from devices in the house.
Well, 90% of the world's noise in radio and electronics is vertically polarized. And so, yeah, when you put a vertical antenna up, it's susceptible to that. But if you get a good ground system underneath it, and the broadcast studies that I read and studied tell you that you have to have a minimum of 15 radials in order to get about 83% efficiency. If you do that, the verticals are amazingly quiet. We took one of the sea matches down to Montserrat, and we had a 90-foot palm tree there, and we used our little air cannon to put a rope over the top of the palm tree, and then we just used vertical radiators made out of number 18 speaker wire at different lengths. And then for radials, we put out 12 radials 65 feet long with speaker wire. We could tune that vertical in 5 minutes and change bands. And it was just amazingly effective and very, very quiet.
In other words, this could be a practical antenna for a ham on a city lot. I would assume that with a vertical, especially you could make it with 3-inch aluminum irrigation pipe. You could also make it with wire, hung from a tree, that if you can put in the ground radials, this could be a very practical antenna for people that want to work DX from their city lot.
Yeah, that's a good point, because the vertical takeoff angle of the vertical, if you have sufficient ground radials, is about 15 to 20 degrees. That's about what a Yagi is at about 70 feet. So it's a competitive type antenna for that. And it can fit into a city lot. And oh, by the way, the big difference is 3-inch irrigation pipe versus the wire idea is that the wider the diameter of the vertical, the more broadband it is. And so that's the benefit of using the 3-inch irrigation pipe. My 20-meter antenna actually worked all the way up into the 14 megahertz. Well, excuse me, I misspoke that. And worked down into the 13 megahertz region. And I actually used it a couple of times to talk to B-52s when our systems were down for the military, because I could just stick my TS-430 on there and clip a couple of diodes, and I could transmit down at that frequency. And it worked. It worked really well, talking to B-52s that were coming into the range to do cruise missile testing. So the wider the diameter of the radiator, the more broad-banded the entire array will be.
Lee, I was thinking in terms of like if you're in an HOA, but it seems to me that you could, just off the top of my head, without knowing anything, if you don't have 3-inch irrigation pipe and you have HOA, could you not create vertical elements that are like a cage vertical, where you've got, say, 3 or 4 wires around a circle, maybe that's 3 inches in diameter, and bring those wires down so that they look like a broadband radiator?
Oh, absolutely. In fact, that's the basis of the old elephant cage antennas that the military used to use, because they were broadbanded and they were large in diameter for that purpose. So yeah, you could do that.
So they'd be kind of stealthy, hanging from the trees in your yard.
And it doesn't have to be even 3 inches in diameter, even an inch or inch and a half or something like that. It'll still give you some broadband improvement over just having a single radiator.
What's the current rig?
Well, I have 2 of them, FT1000 Mark V field and Alpha 76 amplifier. And then I also have a K3 line, and I'm in the process of setting both of them up. I'm going to have the K3 and its accessories on CW and FT8, and I'll keep the FT1000 and the Alpha on the sideband. And so that's the rundown here. Antenna-wise, I have 40 through 10 meter log periodic from M squared at 50 feet. And that's a very big antenna, but a very effective one. And I have a full-size 160 meter inverted V, 80 meter inverted V, and I have a Moxon on 6 meters. And right now I have one of my 40-meter verticals with a top hat on it that I use on 60 meters. And that works really well on FT8 especially.
And what's your favorite operating modes?
CW. I'm more a CW guy than anything. I do like FT8 if I want to take a nap.
Because you can put it in automatic pilot and have it to make contacts for you.
Yeah, exactly. Yeah, FT8's fun. It's kind of like going fishing. You never know what you're going to catch, but on the other hand, I miss the interaction between the hams, and so that's the downside of it. I do like sideband as well. I do a lot of events. I do every year the POWMIA Remembrance Week operation. And I do a Fire Prevention Week operation in September and October, respectively, on sideband mostly. And so I get a little bit of all of it in. I haven't been on RTTY since the Last Supper, but I did have some interest in that a while back, and that's another long story which we don't have time for today.
How did you get involved in QSL card printing?
Well, it's kind of a long story, but the Reader's Digest version is I took my wife on our 25th anniversary to St. Lucia. So I took my rig with me, and I operated portable J6. And I took some pictures down there, which is a beautiful, beautiful island, and brought them home. And I wanted to get some nice QSLs made up for my operation there. And I had to buy at least 1,000 cards, and it was 3 months to get the cards back. And the total quality of the printing was horrible. They were just terrible, terrible cards. And that stuck with me. And so when we started our print shop in 2007, I had this idea of why not do QSL cards, because our printing is all digital, our press is digital. And so, I can do as little as 50 cards or as many as N cards where N is greater than 1,000. It doesn't get economical more than 5,000, but anyway, that's another story. So, so I went ahead and hung out my shingle and had a guy that worked with me put a little website together, which is still up and running. And, people started sending their QSLs in or their photographs in, and I started cleaning up their photos in Photoshop and making QSLs out of them. And it's become extremely popular. And I've got, 260 5 out of 5s on EHAM, and, over the years, and probably close to 3,000 clients now. And they trickle in a few at a time. And I started it as a way to unwind from my regular job as a vice president of R&D. So, so I'd come home at night and do a few cards. So that's how I got into it. And it's just kept going. And I did a little bit of guerrilla advertising. I do all the programs for the DX dinner and the contest dinner at Dayton. And now I'm doing the top band dinner for Dayton. And so that's a big job that I do every April, May, just to get us out there. And yeah, keeps me off the streets, let's put it that way.
What are we doing right about attracting new hams to the hobby?
Well, that's quite a subject. I think that in order to get just masses of people involved in the hobby, getting rid of the code was probably the first thing that caused a flood of new hams into the fray. But with that goes some negativity, and that is that a lot of the hams have just become appliance operators, and they don't know much about antennas, and they don't know much about anything other than operating protocol. And I think that's an element that's missing out of ham radio anymore. My career would have been vastly different if there hadn't been an incentive for me to get into the basic electronics and build my own gear up front and get to the point where you really had some knowledge of how everything acts with other things and just in general how the electronics comes together to make this magical hobby happen. So I think, if you want to get people into it, then I think what's going on now is probably okay. I don't know what kind of fallout there will be into professional lines. I'm sure there will be some, but it's not like it used to be.
Yeah, no, that's certainly true. I'm looking at kits for kids every once in a while, thinking that I'd like to see something that's a little bit harder, and maybe the listeners can send me some links of maybe some kit companies that can provide maybe the same, say, novice experience that we had. We kind of had to roll up our sleeves and get our hands dirty in order to figure out how to make things work. I think that was part of the magic. I think it's still part of the magic for me. Do you still have a workbench, Lee?
Oh, yeah, I do. And I have a lab down in my basement that I'm putting together with a scope and spectrum analyzer and all those kinds of things, signal generator. So, yeah, I have a lab and I have my shack, which right now, if you don't have a tetanus shot, you can't come in.
Yeah, I hear that.
I'm also working with a doctor that I worked with back in the dialysis days that I'm working with him on a new medical device, and we just have the prototype up and running last week. So
it's hard to retire, isn't it?
Yeah, I mean, I learned the first week that daytime TV isn't what it's cracked up to be, and listening to the crickets chirp on the front porch isn't much fun either. So, you got to have something to do. And so he approached me a year ago and he said, what are you doing with your retirement? And basically he's the same way. He's retired. And so we decided, okay, well, we might as well go out with a flash and do something for humanity once again. And so that's what we're doing.
Well, I think that's amazing. Do you have any young protégés in the neighborhood that want to learn ham radio from you, or at least learn some electronics from you?
Well, every once in a while I get somebody asking me a question, but I don't have anybody that's a permanent protégé. They all kind of look at my antenna in awe and decide that maybe that's too scary.
What excites you the most now about what's happening in ham radio?
Well, I'm really kind of excited about the sunspot cycle being back up at a relative high. I had a friend of mine come to dinner a week ago Friday, and he hadn't seen ham radio station before, so I got him his tetanus shot, and he came into the shack, and I turned on the rig, and on 20 meters there was a Russian station that was about 30 over 9 on sideband, and he happens to be of Russian descent, so he speaks Russian, and so I gave the guy a call, and they came right back, and we had a nice little chat for a few minutes. And I offered to let him have a little dialogue in Russian, but he declined. So it's the reason I got into this was because I wanted to be able to talk to people around the world and learn about their cultures and that kind of thing. And I still enjoy that when I have a good set of conditions and. Somebody like yourself in Israel, it would be great to have this QSO on the air. I mean, it's just fun to get to know people.
What advice do you have for new or returning hams to the hobby?
Well, I would say that the best thing to do is to get your general class and get on HF because the 2-meter world is too limited. There's too much easy stuff for 2-meter and 440 and those bands to stay locked into a narrow area of ham radio that you might not really understand what it's all about. But if you get on HF and all of a sudden you're taking a little bit of that current out of the wall and putting a signal into China or Asia or into Europe or someplace, and can actually have a two-way conversation with somebody without using the internet or without using a cell phone, that's still magic in my mind. And I think it's addictive if you get them into it. And I have a friend that I got into ham radio down at Nellis Air Force Base years ago, and he got into HF about 3 years ago, and you can't keep the guy down. I mean, he's in an HOA, and he's found all kinds of very inventive ways to get antennas into his yard so that he could make contacts on HF around the world, and he's always excited about that. And I think that's really where it all lives, personally. So that would be my advice: is don't stop at technician class. Go get your general, get on HF. That's where the magic's at. You asked me a little bit ago about kids that are sort of, what did you term them? Well, people that want to learn or that I've helped.
Proteges.
Yeah, proteges. Well, I kind of fell into one of those when I was working for the Air Force, and I was working in radar. My job was to optimize the performance of our radars here at the Utah Test Range. And I read in the paper about a project that was going on at Weber State University where they were going to build a satellite. The students were building a satellite that would be ejected out of the shuttle bay called the Getaway Special Can. And anybody, any U.S. citizen could buy a Getaway Special Can. They were some of them were 4 inches high, and they went up as large as 18 inches high, and they were 18 inches in diameter. And you could put your own specialized science experiment inside of it and send it into the people at Goddard Space Center, and they'd put it in the shuttle bay when they had room. And there was a guy up at Thiokol that was the president of the booster division, and he put in some money and bought the gas can, the big one. And then he got together with the director of the FAA here locally. Well, he was actually the regional director. And they came up with this idea of measuring antenna radiation patterns off of radars at different airports without having to take them off the air. The problem was if they had a hole in their antenna pattern, then they wouldn't see an airplane, and that would be really dangerous. And so every so often they'd have to take the radars down early in the morning and then watch the sun come over the horizon and use the sun as a noise source to plot their antenna pattern. And they would rather keep them on the air and use a little satellite flying around to measure that antenna pattern. So that was the goal of the satellite. And I read about it in the paper, and I called the guy that was in charge of it up at the college and said, can I fly a beacon on your satellite that the Air Force would buy? And we could use that to calibrate our radars with out here on the test range. And he said, the more the merrier. So I went up, I went up to the university and met with them. And they were more than happy to fly this beacon. And in the process, I found out that they needed somebody to lead the student group for the communications link between the ground and the satellite and the ground. So I kind of volunteered to do that. And so I had originally about 36 students that were really interested in doing it until they found out there was work involved. And then it dropped down to 3 students. And those 3 students stuck with it. And we built the communication system link for up and down. And there were some real challenges with that. We we came up with a way of doing synchronous frequency shift keying so that it was minimal bandwidth on FM radio. And that ended up becoming what's called today minimum shift keying, actually. I gave a paper on that at Goddard Space Flight Center back in the 60s, or in the mid-80s, actually. And long story longer, which I'll try and make shorter, is that we ended up, the satellite looked like a stop sign in 3 dimensions. It was a hexagonal prism, and it had some flat surfaces on it that were 90 degrees to each other. So we put 2 440 antennas on 2 of those surfaces, and then 232 megahertz antennas on a different set of those surfaces. And then we fed those 2 antennas on each band 90 degrees out of phase, which gave you circular polarization. And that way the satellite could tumble, and you always had one form of linear or circular polarization pointing at you. So your maximum signal degradation would be 3 dB. And then on the ground, we used circular polarized antennas. So we had a 500 watt uplink transmitter, and the downlink was about 10 watts. And we used ham radio gear to make this communications link. And for the satellite, we had to take a ICOM handheld and split it out so that it had just the receiver. And on that, we had to replace all of the capacitors with tantalums, because it had electrolytics on it, and electrolytics come unraveled in vacuums. And so we had to put tantalum capacitors all through it. And then we had to do some advanced electronic stuff to get it temperature stable, because we didn't know what temperature it was going to be at. And we had to deal with Doppler. And so we used frequency shift keying on audio, because that's not affected by Doppler. And then on the receiver side, down on the ground, we had some switchable capacitors on the local oscillator of the receiver, so that as the elevation angle changed, going over, it would switch in different capacitors and retune the receiver. And using FM, that's a great thing, because all you have to do is catch enough sidebands on FM and you've got the signal. And so we put all this together, and it was really kind of funny, because the day that it was launched, the president of the college came in, and he had no involvement in the project till it was launched. And then he was beating his chest about what a great thing this was. And he told us, you can't talk to the satellite until Friday, because all the news media are going to be here. Well, we walked out of that meeting, and it was 10 minutes before the satellite was supposed to go across, and everything's ready to use. And I mean, what are you going to do? So we went down to the ground station, and it came over the horizon, and we hit the wake-up call, and it came right back to us, and we celebrated. Well, Friday night came, and the media came, and so we gave the wake-up call to the satellite, and it didn't respond. And it didn't respond the whole night, over 2 passes. And then the next morning and Saturday, we went in there and sent the wake-up call, and it came right back to us. So anyway, there was an issue on board the satellite, which we fixed on the ground, but that's another story which we don't have time for. But the cool part about all this was that this was the very first low Earth orbiting satellite that was ever launched out of the space shuttle. And it was a compression spring. It was a jack in the box. And so you open the lid and then blow some Marmon clamps, and that would poke this thing out into space. And the launcher was NASA certified, which was built by the mechanical engineering students. It was really a cool project for these students to work on. In 1987, I was honored to go back to the Smithsonian Air and Space Museum, and they inducted all of our models and prototypes into the museum. So out at the Dulles extension of the Smithsonian, I have an exhibit out there. So it's pretty cool. So I have done a lot of mentoring through my career, and that's just one of the major ones that I can talk about. So,
are there any links or papers that you could give to me for the show notes for that?
I gave 2 different presentations on this to Goddard Space Flight Center. So they're in the NASA publications, and I can see if I can find the references for those.
That would be great. I'll put those in the show notes page.
Might even be able to scan them. My wife owns a print shop, and it's in our basement. So
you have a lot of capability.
Yeah, we do.
Lee, I want to thank you so much for joining me on the QSO Today podcast. This was really interesting, and I know that the listeners will also find it fascinating. I so appreciate your being a listener to QSO Today, being a contributor to QSO Today, and also for the presentations you've made in the past to the Expo and the Academy. So with all of that, I want to thank you so much and wish you 73.
Well, thank you for the opportunity, and I sure do appreciate it. It's been a business doing pleasure with you. 73.
73, Lee. That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Lee. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in K7NM in the search box at the top of the page. You can sponsor the transcription of this episode or any of the previous episodes by clicking on the transcription button on every show notes page. The cost is $75 per episode, regardless of the length. We will quickly transcribe the episode and give you credit for your sponsorship. Please send us the call sign of the podcast to make sure that we transcribe what you want. Remember that QSO Today is value for value. Please support our project by making a donation or becoming a listener sponsor today. Use our Amazon link before shopping at Amazon, as we receive a small commission on your Amazon purchases. Subscribe to our mailing lists, both my blog and the podcast, and forward the messages to friends and family who would enjoy QSO Today content. Promote us on social media and give us a 5-star rating and reviews whenever you are asked. QSO Today is available on every podcast player and venue, including Apple Podcasts, YouTube, Spotify, and Podcasting 2.0. Get a Podcasting 2.0 player to make it easy to get your next episode as soon as we publish. My thanks to Ben Bresky, who, as the consummate artist, makes this host and his guests always sound brilliant. Ben also publishes a weekly Jewish history podcast. There is a link to that on the QSO Today homepage. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.